Bam. If you want to join me on page 240, I'm going to be on page 240 covering section 4.3. And this is where we get into factoring. And in this section, we're going to focus on factoring out the greatest common factor, and factor by grouping. Let's see, Edson. So let's start with problem number 7. We've got 4x squared y minus 12xy squared. And the instructions say factor. All right, so my first question for you is, how many terms are there? 2 terms. And do those 2 terms have anything in common that I can factor out? Not the squared. But they do both have an x. So I can take out an x. And they do both have a y. And what about 4 and 12? Does anything divide evenly into 4 and 12? 4. So I'm going to be able to take out a 4 also. So we're taking out a 4, an x, and a y. We're taking all of that out, okay? And so now I've got to figure out, what does that leave me with? Well, when you factor out, you're dividing. So what is 4 divided by 4? 1. Look, this x has a squared, but I'm taking an x, so that leaves me an x, right? And I've got only one y, but I'm taking a y, so does he have a y? No. So that's all that I'm left with for the first term is an x. Now, 12 divided by 4, I'm taking the x, and I'm taking a y, so that's going to leave me a y. And that is factored completely. Everybody see how factor out works? The big numbers you divide, and the exponents you subtract. Are y'all ready for another one? Next, number 25. Okay, how many terms are there? Only 2? And do they have something in common that I can factor out? A y and the 3, and the lead term needs to be positive. So I'm also going to need to factor out a negative. Did y'all hear me say the lead term needs to be positive? And so if it's not, you're going to need to factor out a negative. Affirmative? Here we go. Negative 3 divided by negative 3 makes a positive 1. Y squared, take away y, leaves me a y. And next, what is 24 divided by negative 3?
No, 9. 8. Oh my gosh.
You got there eventually. Yes. It sure is. 24 divided by negative 3 gives me negative 8. And I took his y, so he doesn't have a y left. And that is factored completely. And did y'all realize that I can do the distributive property to see if I factored correctly? If I distribute it back in, I should get back where I started, okay? Is that enough factor out that you're good at it now, or do we need to do one more? Another one? Are you good? Okay, so we're going to do one more. Just so that I can make one up. I like making up problems. Ask my wife. She'll tell you. I love making up problems. Let's see. Let's have 18x to the 5th minus 9x to the 4th and 15x squared. Let's go with that. Okay, so how many terms are there? There's 3 terms. And do they all 3 have something in common? Now tell me, how many x's can I take? Just one, or can I take more than one? I can do 2. But do you see why I can't do more than 2? Because this guy at the back, he has only 2. So I can't take more than he has. And so that's going to lead you into a statement that says you can only take the smallest power. When you're factoring out letters, you can only take the smallest power. And what divides into 18, 9, and 15? 3. Now let's figure out what we have left over. 18 divided by 3. 5 take away 2. Y'all see that? We subtract the powers. Minus 9 divided by 3. 4 take away 2. Last, 15 divided by 3. 2 take away 2. None. No x's left. And again, that is factored completely. Does everybody see how factor out works? Okay, so now we're going to move on to the next thing, which is factor by grouping. Factor by grouping. Number 47. All righty, so how many terms are there? 4. Do y'all see the 4 terms? And do they all 4 have something in common that I can factor out? Do they all have a y? The 40 doesn't have one, so I can't take a y. And the lead term doesn't even have a number in front, so I can't take any number out. Yeah, so there's nothing to factor out. But I do want you to realize that factor out has to come first. Y'all understand that? You've got to ask that question at the beginning. So how many terms are there? And that's what tells us factor by grouping. When there's 4 terms, you factor by grouping. Got it? So normally when you group them, you're going to group them the first 2 and the last 2. And then you're going to look inside the first group. And you're going to ask yourself, what do they have in common? And now we're going to take out a y squared from the first group. What will that leave me with? Okay? Look at the second group. What do they have in common? There you go. And we're going to take negative 5 because they both have a negative also. So if I factor out negative 5, what will that leave me with? Why what? Guess again? Plus 8. Now, do you know why it's plus? Yes. Remember I said when you factor out, you're dividing, right? And a negative divided by a negative leaves a positive. Y'all feel that? Hello, you got it? Now, look at what we've got here. And I'm going to use color. Let's throw in some red. Do you see the two things I underline in red? What do they have in common? And since those are the same, we're going to factor that out. We're going to factor the y plus 8 out. And so if I factor out the y plus 8, what will it leave me with? Yeah, Edson coming off with it. Does everybody see that? Look, if the y plus 8 gets factored out, I can cross it out, and it shows me what I'm left with. And then if I want to, could I do the FOIL method and check to see if I get what I started with? I sure could. I'm not going to. I'm lazy, but you could if you want to, okay? So that is factor by grouping. Let's try it again. Number 49. All right, first question, how many terms are there? 4. Listen, is it in descending order? Or are the terms out of order? You know what we need to do first? We need to put them in order. So the first thing we really should do is rewrite it in descending order. If it's not in the right order, you're going to have problems factoring it. Okay, so now that it's in descending order, now we're going to ask ourselves, do all 4 terms have anything in common that I can factor out? 12. 12 divides into all 4 of those evenly? Let's see. 24 divided by 12. 36 divided by 12. 72 divided by 12. You think it's 62?
No, 6.
Oh, 6. 6 also. What about 108 divided by 12? 9. So they do all divide by 12, so we needed to take it out. And now the stuff that's left over inside the parentheses, how many terms are there? And now we're going to need to factor by grouping. All right, so again, what can I take out of the first 2? And what will that leave me with? Good. Good. Take out the x squared. Leaves me 2x minus 3. What can I take out of the second group? Does 3 divide into 6 and 9? Let's take out a 3. What will that leave me with? And did you notice that the stuff in the parentheses matches? When you factor by grouping, the stuff in the parentheses has to match. If it doesn't, you either screwed it up or it won't factor. I'm not done. I am so not done with this problem. So again, let's look at the red. And what do the two red pieces have in common? So we're going to take the 2x minus 3 and factor it out. If I factor out the 2x minus 3, what will that leave me with? And now that is factored completely. And did you notice the 12 that I factored out at the very beginning has to stay all the way down? A lot of people, it's because if I drop it and then try to do the FOIL method, it won't get me back what I started with. And so that's why the 12 has to be there. Now, some people think I can just get rid of that 12, that's legal, and the answer is yes. If it's an equation, if it says equal to 0, then you could divide both sides by 12 and get rid of it. But if it's not an equation, you got to leave it. And that's one of the most common mistakes I see people make on a test, is they'll factor out something and then on the way down it falls off. So make sure you don't drop your 12, okay? How do y'all feel about factor by grouping? Do you think if I give you one that you can do it on your own? Really?
Or like one like 47.
No, one like 54.
I don't know how that looks. I don't know if I can survive.
Okay, well, I'm going to give it to you, and I'm going to give you a minute to see if you can do it. 54.
I might need like 5.
No, you're not getting 5. I'll give you a minute. There you go. Okay, fine. Couple of minutes. All right, F it up. Factor it up. Oh, look at all the absent people. Da-na-na-na-na-na. Oh, look at all the absent people. Come on, you can do it. You can do it. Just factor by grouping. All right, you got it? You got it? I'm starting to go through math withdrawal. Let's do it. So what I'm going to do is I'm just going to go ahead and start with my grouping them two at a time. What does the first group have in common? I see that they have an X and a Y. We're going to be able to pull out an X and a Y from the first group. Y'all see they have an X and a Y both. So if I take the X and the Y, that's going to leave me a 2. x and a y, that's going to leave me an x. Do y'all see that? Hello, do you see that? If I take an x and a y, a 2 and an x. Now, what do the second group have in common? Yeah, well, a negative for sure. And they both divide by 3. 6 divided by 3. And 3 divided by 3 leaves me a 1. And do y'all see that both of the signs change when I take out a negative? Now, does the stuff in the parentheses match? Remember, it has to if you're doing factor by grouping. So the 2 plus x, we're going to copy down. We're going to cross it out. And what do I have left over? So my final answer, I could say x plus 2, xy minus 3. And let's see if you agree with that last step. Does everybody agree that 2 plus x is the same as x plus 2? Is addition commutative? That means addition, does it matter what order it comes in? No, so I can switch it around, right? What if I wanted to rewrite it like this? Is that also correct? Okay, what operation is indicated right here? Multiplication. What is 2 times 3? 3 times 2? If I switch the order, does it still give me the same answer? And so since that's multiplication, yeah, I can switch them around. It means the same thing. So the order doesn't matter. It sure doesn't. How's that? Factor by grouping. Y'all ready to move on to the next section? Okay, here we go. Next section, 4.4. That's going to take us over to page 245. And we're going to start with problem number 1. Oh, and I guess it'd be nice if we knew what this section covered. We're still factoring. But this section is factoring standard trinomials. Factoring standard trinomials. A standard trinomial is a trinomial that does not have a lead coefficient. All right, number 1. Factoring standard trinomials. Are you ready to receive my instruction? Okay, here we go. How many terms are there? 1, 2, 3. Do they all have something in common that I can factor out? But you got to check for it, right? Is it a standard trinomial? That means, is there anything in front of the x squared? No, so it's standard, and that means we're ready to F it up. Let's factor it up. The first step is parentheses. The second step, read the signs. So if there's a plus at the back, you have to look at the front, and that's what they both are. A plus at the back says these are the same, and they're both going to be whatever the first sign is. Got that? So the steps, parentheses, read the signs. Third step, fill in the blanks. What does it take to make x squared? X times x. So I need an x and an x. And in the last 2 blanks, I'm going to have numbers that multiply to make 36 and add to make 13. Can you think of two numbers that multiply to make 36 that also add to make 13? 13 and 2. Is 13 times 2 26? Yes. But 13 plus 2 does not make 13. So it almost worked. So think of two other numbers that multiply to make 36. 3 and 12. And does 12 plus 3 make 13? Oh, that's fine. We're guessing right now.
9 times 6.
6 times 9?
9 times 7.
7 times 9?
Yes.
7 times 9 is 63.
Oh, wait, that's 9. Was it 4 then? It was 4. I don't know why. Good job.
I don't know either. But do y'all understand it's kind of a guessing game? You try to figure out what numbers multiply to make 36, and then those numbers have to add to make 13. Do y'all understand? It may take you a few guesses to get it. What if you're not good at guessing? Takes you a while, right? Would anybody like a systematic approach to that? Let me show you what I do, okay? So when I'm looking for the numbers, I start with the easy ones. I know that 1 times 36 makes 36, but does that add to make 13? And then you go systematically. 2 times 18 is 36. 3 times 12. And then eventually you come to 4 times 9 and you get there. And do y'all see that is very systematic? You go 1, 2, 3, 4, looking at numbers that multiply to make 36, and then you find the ones that add to make 13. And that is done. Listen, it's a simple 3-step process. Factoring standard trinomials. What are the 3 steps again? Parentheses, read the signs, fill in the blanks. Parentheses, read the signs, fill in the blanks. Y'all ready to try another one? Number 9. How many terms are there? Is it in descending order? Good. It needs to be, right? And do all 3 terms have anything in common that I can factor out? No, but I got to check for it, okay? So it's a standard trinomial. First step, parentheses. Next, read the signs. This time there's a minus at the back. And a minus at the back makes them different. Okay, now do y'all see that a plus at the back makes them the same? And a minus at the back makes them different. What does it take to make p squared? Look, I got a pp. And then I need numbers that multiply to make 54. This time they need to subtract to make 3. Numbers that multiply to make 54 and subtract to make 3. 9 and 6. Now, where does the 9 go? With the plus or the minus? Yeah. And it matters where you put them, right? So if you're wondering how the freak do I tell which goes where, I need a positive 3. 9 minus 6 makes positive 3. That's how you tell. And that is factored completely. Could I FOIL it and check? If I want to FOIL and check, I can, okay? Are y'all ready to try another one? Okay, next, 23. And the instructions say factor. want to factor completely. How many terms are there? Is it in descending order? Uh-oh. First step, rewrite it. So the minus y to the third goes first. Next. Plus 4y squared. Next. And so now that's in descending order. And now did you notice that the lead term is negative? That's a problem. That means I'm going to have to factor out a negative for sure. Do all three of those terms have anything else in common? Let's take out negative y. Let's see what happens if we factor out negative y. So negative divided by a negative leaves a positive. We're going to have a positive y squared. Positive divided by a negative. Careful. And positive divided by negative leaves a negative 32, and I took his y. He is y-less. Now, look what I've got inside the parentheses. Inside the parentheses, is that now a standard trinomial? Let's F it up. So we're going to start with parentheses. Can you read the signs? Minus at the back. Minus at the back makes them different. What does it take to make y squared? Yeah, y times y. And now for the big question. I need numbers that multiply to make 32, that subtract and make 4. Yep, 4 times 8 is 32. And 4 minus 8 is negative 4. 4 minus 8 is negative 4. And that is now factored completely. But it's also factored correctly. Anybody have any questions? No, I'm doing that good, huh? You don't have any questions? Okay, let's see if you can handle the next one. Number 27. Bam, take that. I mean factor that.
Or is that actually factor?
Are there numbers that multiply to make 7 that add to make 3? What are the only numbers that multiply to make 7? And they definitely don't add to make 3, right? So this is not factorable, but the actual word that I need to see from you is prime. If something doesn't factor, it's called prime.
Because of the prime numbers? Because of the prime numbers? Or just like?
It's like prime numbers. If you think about what a prime number is, it's a number that won't factor other than 1 in itself. It has no other factors. And so we're saying this has no other factors. So it's prime. So it's like a prime number. Yeah. And if this was an Autobot, it would be Optimus Prime. Yeah, Optimus Prime. All right, number 31. I didn't use that joke in the last class. I'm glad I didn't. And this is the last problem that I absolutely have to do before we can move on to the next section. All right, so tell me, is that trinomial in descending order? And is there anything that all three terms have in common? And did you understand that factor out has to come first? If something will factor out, it has to be done first. So we're going to divide everybody by 2. And then we're left with a standard trinomial. So we're going to try to break it down. Right? The stuff in the parentheses is now a standard trinomial because there's no coefficient of x squared. Can you read the signs? Minus at the back makes them different. X and x to make x squared. And finally, I need numbers that multiply to make 45, that subtract and make 4. Anybody? Yes. 5 and negative 9. 5 minus 9 is negative 4. 5 times 9 is 45. And that is factored completely. How do y'all feel about factoring standard trinomials? You feel good about it? Because you know what we're about to do? We're about to move on to the next section. 4.5. Add a page. Section 4.5. And this section is also on factoring. But in this section, we're going to be factoring trinomials with a lead coefficient. And this is going to take us to page 253. If you need to know that, page 253. Factoring trinomials with a lead coefficient. Starting with number 1. Okay, so how many terms are there? And that makes it a trinomial. Is it in descending order? And do all 3 terms have something that I can factor out? Does anything divide evenly into 3, 14, and 5? Don't think so. And they don't all have an x? No. So there's nothing to factor out. But did you notice this time I do have a number in front of the x squared? That 3, that is my lead coefficient. And when there's a lead coefficient, you're going to use the 3R method. I'm going to get to teach you my patented 3R method. Okay, it's not really patented, but it should be. The 3R method. What are the 3 R's? Remove, replace, and reduce. This is my technique for factoring a trinomial with the lead coefficient, the 3R method. Are you ready to see how it works? I'm sorry, are you ready? I'm not getting everybody to buy in. Ready? Okay. So it turns out when there's a lead coefficient, this becomes harder than it should be to factor. So we're going to remove it. Okay? Did you see? Look, I removed it. But I can't just trash it. I got to do something with it. And so here's what we're going to do. Can y'all see what that says? The 3 that I remove, I'm going to take it to the back and multiply. 3 times 5? 15. Now, by removing the 3 on the front, I now have this as a standard trinomial, which is what we just got through doing, and you should know how to F it up. Can you read the signs? Minus at the back makes them different. X and X. See how easy that is now? X and X make X squared. And I'm going to need numbers that multiply to make 15. That subtract and make 14. And I heard you say negative 15 and 1, which is fantastic. And now this is factored, right? But remember, we're doing the 3R method. So now it's time to do the second R. What did I remove? The 3. Now I have to replace it. And do you see that when I replace it, I put it back in front of each X? And then it's time to do the third R. Reduce. In the first set of parentheses, can I reduce 3 and 1? Will 3 and 1 reduce? No. And so that comes down. In the second set of parentheses, can I reduce 3 and 15? What goes into both of those? So I can reduce those by 3. That'll leave me X minus 5, and I'm done. That is the 3R method. Remove, replace, and reduce. There's also a method called the AC method. Does anybody remember being taught that in high school? The AC method? Yeah, that's a very common technique, is the AC method. I don't like it, so I don't use it. I much prefer the 3R method. And there's also a technique called multiply, divide, and slide. That one's kind of cool too. Y'all want to see that one or not?
I think we should stick with the 3Rs.
Okay, so most students, they're like, don't clutter my mind with lots of different techniques. Just teach me one way that works every time, and I'll just get good at that one technique. Are y'all okay with that? Okay, we'll stick with the 3R method. Number 13. And the instructions say factor. So how many terms are there? 3. And do they all 3 have something in common that I can factor out? What? What do they all 3 have in common? A 3. Did y'all notice that 18, 51, and 15, all 3 divide by 3? And so we need to factor out that 3 at the beginning. 18 divided by 3? 51 divided by 3? 15 divided by 3. Now, once I factor out the greatest common factor, notice that the trinomial that's left over, it still has a lead coefficient. So we're going to have to do the 3R method again, okay? So what's the first R? So we're going to remove the 6, and we're going to take it to the 5 and multiply. That's the remove step. We're going to remove the 6, times it by 5. Now we have a standard trinomial. Let's F it up. Let's factor it up. Can you read the signs? What are the signs going to be? What? Yeah, they're both going to be negative. Y'all see how to read the signs? I don't feel it. If the last sign is a plus, these have to be the same, right? So they're either plus plus or minus minus. You have to look at the first one to see what they are. And then I need an A and an A to make A squared. And last but not least, I need numbers that multiply to make 30. I didn't even get to finish. That's okay. Look at you like a panther. Oh, you're going to pounce on it. Multiply to make 30, add to make 17. What did you say? Okay, 2 and 15. Now it's time for the second R. What do I need to replace? The 6. Whatever you remove, later you have to replace. And what's the third R? Reduce. In the first set of parentheses, can I reduce 6 and 2? Yeah, they'll divide by 2. And in the second set of parentheses, can I reduce 6 and 15? Yeah, they'll reduce by 3. And do y'all see that sometimes you can reduce both sets of parentheses? And do y'all see how to tell what to use? Whether it's a 2 or a 3, it's whatever goes into them. So the final answer is going to be 3 times 3a minus 1 times 2a minus 5. And that is factored completely. Anybody have any questions on that problem? Anybody? Questions? Are y'all ready for another one? Okay, here it comes. Number 33. Negative 8t to the third minus 8t squared plus 30t. And I need you to factor that completely. Factor completely. And I don't know if you've noticed, but I've been asking you questions at the beginning. I'm trying to train your mind how to think at the beginning, okay? So what questions have I been asking? What are some of the questions I ask at the beginning every time? Oh, yeah. What do they all have in common? Do they all have something in common? What? T, for sure, and a 2. Right. And the negative. Why do I have to take out the negative? Because the lead coefficient is negative, and the lead coefficient should be positive. So that always has to be done first. Factor out has to come first. Now, what am I left with? Keep going. Okay. I got your 4t squared. 4t minus 15. Everybody understand why the 15 is minus? Everybody understand why it's 15? Now, what's inside the parentheses? Inside the parentheses, we have a trinomial with a, yes, we have a trinomial with a lead coefficient, and that is what tells me 3R method. Trinomial with the lead coefficient. In your brain, you should go, uh-oh, 3R method. So what are we going to do with that 4? Anybody happen to know what 4 times 15 is? And then once you turn it into a standard trinomial, removing that 4, then you're going to need to break it down. Can you read the signs? Minus at the back makes them different. T and T. T and T. And numbers.
Negative 6 and 10.
-6 and 10. -6 and positive 10. Now, do y'all see why it's those two numbers? 6 times 10 is 60. 10 minus 6 is 4. Multiply to make 60. Subtract to make 4. Got it? And that's my final answer? No, I'm doing the 3R method. Now I got to take this 4 that I removed and replace it. Dot, 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 dot. Yeah, the most common mistake people make doing the 3R method is they forget to do the last 2 R's. Okay, so I replaced the 4. Now does 4 and 10 reduce? By 2? What about 4 and 6? By 2. And did y'all also notice that the negative 2t that I factored out at the very beginning has to ride all the way down? Don't drop the negative 2t off on the way. 2t plus 5, 2t minus 3. And then if I wanted to, I can multiply all of that out, and I should get the original problem. Man, this is fun stuff. Doing the 3R method. I don't know if y'all remember doing this in public school, but they teach the technique called guess and check, where you have to guess what you think it is, and then you have to FOIL it to see if you're right. Yeah, that technique sucks. So if I give you another one, do you think you can now do it on your own? Do you think you have enough practice at the 3R method to do it? I'm going to give you an opportunity. Number 47. There you go. I'm going to give you a couple of minutes and see how far you can get factoring that trinomial. I need it factored completely. How you doing? You making progress? Everybody checking their Snapchat and Instagram real quick? Three-R method. Remove, replace, and reduce. Oh, I see that. I see. Anybody ready to go over it and see how you did? Or for some of you, see how it works? Are you ready? All right, here we go. I've got a standard trinomial, right? No, I don't. I've got a lead coefficient, the 9 out front. And by the way, this is in the right order to factor this. You don't need to rearrange the order here. So the 9, since it's the lead coefficient, what do I do with it? And multiply. So that's going to give me 225 at the back. X squared minus 30xy plus 225. That's a big number. That is a big number. But now that I have the 9 gone, this should be pretty easy to factor. Let's break it down. Can you read the signs? They're both negative. Affirmative? And now look how easy. X and X. Bam. X and X. Hey, look at this. Y and Y. Do y'all see I'm going to need a Y and a Y to make a Y squared? That's pretty easy. And now for the big question. I'm going to need numbers that multiply to make 225 that add to make 30. Multiply to make 225, add to make 30. It is. 15 and 15. 15 times 15 is 225. 15 and 15 makes 30. Okay? So we removed the 9. Now we need to replace the 9. And then we need to reduce if possible. So what goes into 9 and 15? And did you notice this is identical? So that's going to be 3x minus 5y times. And is there any way to shorten that? There you go. Since those factors are identical, I can write it as a square. That is a perfect square trinomial. How cool is that? I think it's cool. Yeah. Now, do y'all have any other questions about anything I've done today? Is there any other problem you would like to see another example of? Or do you want to take some time and work on your My Math Lab? Okay, so I'm going to go ahead and